Okay, so last time we were here, we began our look at factoring. And what we're going to do over the course of the next couple of classes is just expand the idea of factoring so that we can complete every concept that we need to be able to factor anything that will indeed factor. And we said that the first thing we do when we're factoring anything is look for the what? GCF, which stands for greatest common factor. That means anything that will divide, the largest thing that will divide how? Evenly into every single term. Good. It can be a number, it can be a letter, or it can be even an entire what? Parentheses, right? Study those notes. If y'all can't quote them back to me, then you're not knowing it well enough to be able to really do it every time. Okay? So, even an entire parentheses. And remember it says look for, why? There may not be one. Okay? If there isn't, what factor divides evenly into everything? Or the other word for that is prime. Good. 1 is the only thing that factors into everything, divides into everything, or later you're going to write that as prime. Okay? Then, when you look for the GCF, when you're doing that, what do you look for first? Parentheses. Then you're going to look at all of the coefficients, and finally you look at all the variables. Remember, there can be more than one variable that's a GCF as well, right? When you're doing the GCF for variables, which exponent do you use? The lowest one, right? The smallest one. Okay? Good. So, you had some homework dealing with GCF. How'd that go? Good. Pretty good? Horrible? I hope not. Could have. So, any of those y'all want to see? Any of those you need to see worked?
Please.
Like? You got to tell me. You got to tell me which one. What you got? Were you not here? Oh, you were here. Okay. Okay. Now, any of them you want to see, or just bring one, and I'll be happy to do it, because I don't have your homework. Remember, everybody's homework is going to be different, because like yours is going to be this different from. So, anytime you want to see any of them, just bring one with. Okay. Okay. All right. Then today, what we're going to do is we're going to move on to the second step for factoring. Now, this second step has lots of parts, because the second step is always the same, but what happens to you depending on the answer to this question can lead to lots of different things. So this is where most of the stuff in factoring takes place. The second thing you want to do is to simply count the number of terms. Now remember, on that first day we talked about the difference between algebra and arithmetic was the introduction of the letters, and when you introduce the letters you no longer have just numbers, you have terms. And what is the first part of every term? Does anybody remember?
Sign.
The sign. Good. So every time you see a plus or a minus, that tells you that that's the beginning of a new term. Okay? Okay. So, and we need to know how many terms, because that's going to determine the method that you'll use to factor it. Every time you change the number of terms, you change the method you're going to use for factoring it. Okay? So you have to know how many terms there are, right? This is just like going to the grocery store, right? You can get in your car and go anywhere, but you need to know where you're going to be able to know which directions to go, right? So make sure that you count the number of terms. Again, why? To determine the method that you're going to use. Good. And the first one we're going to look at is what happens when you have exactly 4 terms. This is the biggest one we'll ever factor. You're never going to factor anything bigger than something that has 4 terms. But something with 4 terms uses a factoring method called grouping. Now think about when you're grouping things together. It means you're gathering things together into a little pile, right? Okay, so we're going to be doing that with these terms in order to be able to factor. Because what you're going to see when you're factoring with grouping is that there's usually not a GCF for every single term, but if we group them together into little pieces, then we'll be able to find the GCF for them. So really all we're doing is finding the GCF again. Okay? But we can't do it for all 4 terms at one time because there's not one. So what we're going to do is factor by grouping. So let's look at the steps for factoring by grouping. The first step for factoring by grouping, okay, is to simply separate the first 2 terms from the second 2 terms. Because remember we said in order to use grouping you had to have 4 terms. So what we're going to do is separate the first 2 from what? The second 2. So in other words, we're going to split it in half. And there are lots of different ways of doing this. Doesn't matter how you do it. You can, in Course Compass, if you do the help me solve this thing or whatever, they rewrite it and separate it and put a big space between the 2 groups. What I usually do is just draw a line, and you'll see that when we do some examples. And what that does is it creates not just one long problem with 4 terms, but 2 groups of terms. And that's where the phrase grouping comes from. Okay? Then, the second step has lots of parts. Oops. The first thing you want to do is find the GCF in the first group. GCF means anything to divide in how? Into both, every term, which in this case is going to be a group of 2 terms, so it has to divide into both, right? Now, notice that this time I didn't use the word look. What did I use? So there's going to be one, right? Period. There has to be. And if there's not, then we'll talk about that in just a second, because that means something else has to be done. Second, bring down the sign of the third term. Whatever that sign of that third term is, just bring it straight down. You're going to need it in your factoring. Okay? Nobody ever told me that. Drove me crazy. They always say, well, try it as a positive. If that doesn't work, try it as a negative. Well, then years later I realized it's always whatever the sign that is, the third term, just bring it straight down. I'm not expecting you to rediscover all of these things. I expect you to know how to use it, though. Okay? So make sure that you do what with the sign of that third term? Bring it straight down. I don't know why people don't want to make your life easier. All right. Third step for this piece is to find, not look, but find the GCF in the second group. Find the GCF in the second group. So is that a suggestion that you just look for it? No, it's going to be there. You've got to find a second factor. Now, this is where it gets, one thing gets a little odd here. It says find the GCF in the second group. In other words, I have to divide out something. But say like you have 3 and 5. Is there any number that divides into 3 and 5?
No.
Yeah, there's one number, right? 1. But normally, would you ever divide by a 1?
No.
Because you get right back to where you started from, right? But in this particular case, this is the only place I can ever think of that you would divide by 1. You must divide by something even if it's just a 1. We have to divide out a GCF out of that second group, even if it's just a what? A 1. And the reason for that is I have to end up with 2 sets of parentheses. If I don't, this method won't work. And the only way to get a parentheses is to put the GCF in front of a parentheses and go back and divide. Right? Remember, that's the format, GCF in front of a parentheses. So I have to get parentheses, so I have to divide by something, even if it's just a 1. Next. The parentheses, because remember, when you divide, you get the GCF in front of a set of parentheses. The parentheses must match. They have to be identical. I've just done, but okay. So there is no GCF for every single term. So the next thing we need to do is we need to count the number of terms. How many terms do I have? 4 terms. And 4 terms factors using the process called what? Grouping. The first step in grouping is simply to separate these first 2 terms from the second 2 terms. And you can write it, rewrite it, or you can just draw a line between where they break. It doesn't make any difference to me how you separate them, but you have to get them in the right spot. Okay? Once you have them separated, what's the next step say I need to do? Find the GCF in the first group. Good. Well, there's nothing common to 7 and 1, but what do these 2 terms have in common? M. An M. So, put the M in front of a parentheses, then go back and divide. 7M, divide out the M, you're left with 7. Plus Mn, divide out the M, you're just left with N. And close the parentheses. So exactly the same thing that we did last time. Common factor. What do I do with this plus symbol? Bring it down. It's never going to change, but you have to have it. So just bring it straight down. Then I'm going to look for the GCF in the, or not, sorry, not look, but what? Find the GCF in the second ones. What do I divide into 63 and 9n? They'll both divide by 9. Open up a parentheses and divide. 63 divided by 9 is positive 9n. Divide out the 9, you're left with positive n. What do you notice about those 2 sets of parentheses? And they have to. So I'm going to get 7 plus n in the first parentheses times what? M plus 9 in the second one. And that thing is your completed answer. Okay. So all we're doing is taking something that didn't have a common factor, breaking it into pieces so that we can find the common factor, and then we end up with something that's common to both of them, the parentheses. The process never changes as far as the rules. All that can change is the way the numbers are, what numbers you have, and the way the numbers and terms are organized. Okay? So, let's look at another one. 8s plus 28t minus 10s minus 35. So if you know what it means to get a GCF, then you know all the math you're going to need to make these work. The rest of it's just how you organize it. First thing, we're told to factor this. When you're factoring anything, the first thing you look for is a GCF. Is there anything that will divide into 8, 28, 10, and 35 at the same time? No. Is there an S in all of them? Is there a T in all of them? No. So, that means that there's no common factor for all of them. What's the next thing you need to ask yourself? Number of what? Terms. Why do I need to know the number of terms? To know which method to use? Okay, good. How many terms do I have here? 4. And the method for factoring something with 4 terms is called grouping. To factor by grouping, the first thing I need to do is what? Separate the first 2 terms from the second 2. So where would this one split? Right after the positive 28t, or right in front of the negative 10s. I don't care how you say it, just as long as you get it in the right spot. Okay? Now that I have them separated, then I'm just going to do what? GCF where? Find the GCF for the first group. 8 and 28 will both divide by what? 4, good. Is there an S in both of them?
Yeah, no.
Nope, so all I can do is divide out of 4. Go back and divide by 4. 8s divided by 4 leaves 2s. Positive 28 divided t leaves, what kind of 7t? Positive 7t, good. Not good enough to say the number, you got to have to say the sign too, because remember, you have to have a sign in between them. Then what? Bring down this sign, it always just comes straight down. What's common to 10s and 35? But remember, you already have a sign there, so we're going to be dividing by what kind of 5? So it's going to change the numbers and the sign. So negative 10s divided by negative 5 is positive 2s. What that was. Negative 35 divided by negative 5 is positive 7. Did I write this one wrong? 8s, es. Sorry. There was a t after that s. Sorry about that. So that means the common factor up here was not just 4, but what? 4t. Sorry. Which means that t would have divided away. It would help if I wrote the problem down wrong. Right? Okay. Wrong? Okay. So I'll quit and go for yogurt. Now, what do you notice about the two parentheses? They match. If they don't match, then you've done something wrong, like write it down wrong. Yeah? So at least you know how to, you can check it. So, what's in the first parentheses? Times what?
14 minus 5.
There you go. That becomes your completed answer. So be careful to write it down right. All right. Now the only thing, yes?
It doesn't matter, like, if I put the 14 minus 5 and then the 2s, that doesn't matter?
Not at all. The order of the parentheses doesn't make the slightest bit of difference. As long as the stuff in the parentheses is the same, the order makes no difference at all. So you can write 4t minus 5 times 2s plus 7. Those two things mean exactly the same thing. Because remember, when you're multiplying, the order doesn't matter. Good question. All right. Now, we're just going to look at a couple more because I don't know which ones do what I'm trying to figure out what they do until you get into the problem, so it won't hurt. And this is the only thing we're going to do today, so you need to be able to see examples of everything that can happen to you. All right. First thing, we're told to factor this. The first thing you do when you're factoring anything is look for the GCF. Is there anything common to 15, 10, 3, and 2? Is there an R in all of them? A Y? An X? So no GCF. Next step is to what? Count the number of terms, right? Not grouping, right? That's not the next step. The next step is to count the number of terms. Why? Know how many, know which method to use. Then how many terms do I have here? 4 terms factors by grouping. So first step in grouping is to what? Separate the first 2 terms from the second 2, which makes 2 groups. And then I'm going to do what? In the first group. 15 and 10 will both divide by 5. There's an R here and there's an R there, so we can take out an R. So we're going to divide by 5R. 15 divided by 5 is 3. R squared divided by R is R. Plus 10RY, divide out 5R, you're left with what? 2Y. Good. What about the minus? Bring it down. 3 and 2 won't divide, but what is common to these two? X. But there's already a sign, so what we're dividing out is a negative X. Negative 3XR, divide out the negative X, you're left with 3R. Negative divided by negative is positive. Divide out the X, you get 2Y. What do you notice about the parentheses? And they have to. So we get 3R plus 2Y times what? Or the other way around. If you write it the other way around, it makes no difference. Okay. All right. 30x to the third minus 42x squared plus 5x minus 7. We're told to factor this. The first thing you look for when you're factoring anything is the GCF. Is there a GCF for every one of these terms? No, there's no x in all of them, and they won't all divide by the same number. How many terms is that? 4 terms factors by? So I'm going to first break it in half right after the negative 42x squared. Then find the GCF in the first 2. 30 and 42 will both divide by what? 6. Yeah. If you said 2 or 3, they do work. That would divide in, but it's not big enough, right? You make sure you get the biggest one. What else do you notice is common to both of those? There's an x, but I need to take out the most x's possible, which in this case is x to the second, right? Because if they have exponents, which exponent can you use? The lowest one, the smallest one. Be careful with that, yeah. Divide it out. 30x to the third divided by 6x squared is 5x's. Negative 42x squared divided by 6x is negative 7, period. Okay? Because the x squared divided by x squared will divide away. What do I do with this plus? Bring it down. Then I have to divide out the common factor for 5x and 7. What will divide into 5x and 7? It doesn't look like anything, right? But remember, this is the one and only place where I have to divide out something, even if it's just a what? So even though the only thing that divides into is a 1, we need to divide it out. Because I have to get those 2 sets of parentheses. Because the parentheses have to match. Well, if you don't have two sets of parentheses, then they can't match, right? Well, if I divide by 1, it won't change anything. Just get 5x minus 7. But what do you notice about the parentheses? They match. So I get 5x minus 7 times what? And there's your completed answer.
Will there ever be a 1 in the first half?
No. If there is, then something's weird about it. And hopefully we'll get there. Okay? So, are you noticing that I'm not asking any different questions on any problem? So many times when you're taught math, you're taught by example. And in the examples, they all look different.
Yeah.
But what's going on? I'm not teaching you by example. I'm teaching you what? The method. Right? And if you can ask yourself that series of questions, first of all, you have to be able to tell what kind of problem you're dealing with, right? You have to know it's grouping. But then once you know it's grouping, if you can walk yourself through those questions, then the math is easy. Right? So make sure you retrain yourself to think that way. Think method. The method tells the problem what to do, because the problem can't tell you what to do. It doesn't work that way. Okay? Let's look at another one. Y squared plus 12x plus 2y plus 6xy. All right. We're told to factor this, so the first thing we do is look for a GCF. Is there anything common to all of these terms? Is there a number that will divide into all of them? No. Is there an x or a y in all of them? No. So there's no GCF for all of them, is there? How many terms is this? Which factors by? Grouping. So I'm going to break it in half right there in front of the positive 2x squared. Make sure if you're going to draw a line, make sure you draw it thick enough to know that it's not a 1, okay? Then I'm just going to find the GCF where? In the first group. What's common to y squared and 12x?
1.
Just a 1. Watch what happens, though, if we do that. Divide by 1, that gives me y squared plus 12x. Bring down your plus. What's common to these two? 2 and a y, which gives me 1 plus 3x. Can you divide them out? Is that good?
No.
What's wrong with it? The parentheses don't match. And in this particular case, the only way this will work is if the parentheses match. And every one of these in this exercise set will factor. So this one has an issue from the very beginning. Now normally, it doesn't make any difference what happens from the beginning. You can just factor it. We didn't rearrange or do anything else to any of the others, did we? We just used them the way they came. But if the parentheses don't match, what that's going to tell me is they're not in order. What's the order called? For when you're dealing with polynomials? Descending order. Hopefully back somewhere in your murky distant algebra past, somebody has told you about descending order. What does it mean to descend? Yeah, you're going down, right? From the highest exponent to the lowest exponent. Okay? So descending order is always from highest to lowest exponent. And if you have more than one letter, you have to think about the alphabet. And we really should reverse those. Think alphabet first. But normally you don't have more than one letter, but in this one we do. So alphabetical order, and then from highest exponent to what? Lowest exponent. I'm sorry, sir. You had your hand up. Did I answer your question? No? You
Yeah,
didn't?
you did.
Okay, good. Okay. Sorry. So once I get on a roll, it's hard for me to stop. So let's look at this problem again. Now, you never know that you're going to have to do this until the parentheses don't match. Don't rearrange everything you see when it's got 4 terms. We didn't rearrange any of the others before this, and we did 4 or 5, right? Only try to rearrange them if you find out that when you try it, the parentheses what? Don't match. Okay? If the process fails, then go back and rearrange. Otherwise, you're going to be killing yourself trying to rearrange problems that don't need to be done, don't need to be rearranged. Okay? This doesn't happen very often, but when it does, we want to rearrange them. Now, if you look at this, which letter comes first, X's or Y's? X's. Okay? And if you look, there are two terms with an X in them. You see that? So, I need to see which one of those to put first. Yeah, and what I want to do is, I want this the plain old X. Now, if there was an X squared, that would be the first. But is there any of them with X squared in them? No. So the one that I want first is the one with the plain old X in it. Nothing else. So that's that one done. Which term do you think should come next? The plus 6xy. So anything with a plain old X, and then anything that has an X and another letter in it. Do you see the logic there? Now, I'm done with the ones that have X's in them. So now I need to do the ones that have Y's in them. But remember, we're going in descending order according to the X's, which means the Y's are going to go in the opposite order. What's the opposite of descend? Do you remember? Ascending order. So which Y term am I going to put first here? The 2Y. If you're putting it in order by X's, then the X's will go from highest to lowest, but any other letter will go from lowest to what? Highest. So what term should come next? Positive 2y, and what has to come at the end? Plus y squared. Okay? Now, you could have put this in descending order by y's instead if you wanted, and it would work exactly the same. What if I was going to put this in descending order by y's? Which term would come first? The y squared. Then what would come next? Plus 2y, because it doesn't have anything else in it. Then what would come next? Plus 6xy, because it has a y in it. And then finally, what would have to come at the end? Plus 12x. Now that's descending order as well, but it's not in descending order by x's, it's in descending order by what? Y's. And it makes no difference to your answer, which one you choose. I would probably have done this one, because it had a y squared, and the x's didn't have a square. I usually do it by exponent before I do it by letter. But what if there was an x squared and a y squared? Which one would you use? Either one, right? Doesn't matter. Typically, I would choose the x squared then. So let's look at it now with it in that order. Y squared plus 2y plus 6xy plus 12x, right? The way I had it. Break them in half. What'll divide into the first two? Y. Divide out the y, you get y plus 2. Bring down your plus. 6 and 12 above by 6. There's also an x in both of them, which gives me what? Oops, sorry. Y plus what? 2. What do you notice about the parentheses this time? So I get y plus 2 in the first parentheses times what? And there's your completed answer. Now if we'd done it with the x's, what we'd have gotten was 6x plus y and 2 plus y. But they mean the same thing. Okay? All right, let's see. So if your parentheses don't match in this particular exercise set, then what does that tell you about your original problem? It's out of order. So just reorder it. Either order it by the x's or the y's, or if you have a's and z's, you'd use a or z. Doesn't matter, make any difference, right? But which letter used doesn't make the difference. But the biggest one comes first, then move on from there. All right. But keep in mind that the process of grouping never changes. First, separate the first two terms from the second two. Find the GCF in the first group, I'm sorry. Bring down the sign. Find the GCF in the second group, even if it's just a 1. Parentheses have to match. Then divide out the common parentheses. And again, when do you use grouping? When there are 4 terms. So you see what I did then? went from the steps to the when to use it, and because you need to know backwards and forwards. You need to know when to use it and what the steps are, and you need to know the steps well enough to tell me when to use the steps, what process it is, backwards and forward. Okay. Again, we're taking factoring pretty slowly here. This is where we're going to stop today, because I want you to immerse yourself in each one of them. But then, in a few days, we're going to get to a lesson. We've got 2 more days of factoring, and then I'm going to give you a factoring lesson that puts it all together. So learn it in isolation, that's fine, but study what you did the day before as well, because if you're going to have to put it all together at some point. So a lot of students can get it piece by piece, right? I can do factor by grouping, that's all you give me. But you've got to put them all to be able to put them all together. So keep that in mind. Study both things. Once you do the homework on this, then you might want to go back and review your notes on what we did before, the GCF ones. Right? Don't forget what we've done before. Okay. Well, then next time what we're going to do is we're going to just continue looking at factoring, more method. We've got 2 more days. There are 2 more types of factoring, 2 more factoring methods that we're going to look at. Okay. If you're going to be absent, Thursday would probably be about the worst possible day for you to be absent. Just saying. Okay? Because you'll be in trouble from then on, I'm thinking. All right? So, let me call the roll.